this is still PO1, operational research. You have PO2. Yeah. And this is also like mathematical optimacy, previous class. Okay? It's the backbone of industrial engineering. While the management part is different. Okay? So you must like or re-like the math. Using basically math and logic. Alright? Usually the grade, we will have some homework. You'll have, of course, the SYS, yeah, we can final exam, but usually the exam is say 25%, 30%, and the PR or the homework is 20% each session. But it's not that strict. Yeah. The main thing is this: you need to make sure that you learn this. Yes, you already familiar with each subject matter. Each question, the homework or exam has to include this. Okay. Yeah. And is it the same ketua kelas? Or this different you?
Amin.
Okay. Is it all class with him or?
No.
Only Professor.
Okay. Yeah. So I'll share the PPT after we finish. Okay. Here. Now let's just go straight to the mandat. Introduction, which so operations research is discussed. Yeah, the history is the original name is actually military operations research. Because it was developed in the World War II, Second World War, when the British military asked scientists and engineers to find solution for logistic problem. And the logistics are for military, so it's ammunition, tools, people, soldier. So it's very critical. And if they're late, then a lot of people will die. If the ammunition is late, they cannot use their rifle. Or the food, they need supplies of food and clothing and so on. Yeah. So the British military saw that we need something different, something that is more focused on how to take care of this logistic in chaotic condition. Which time, cost, is very sensitive. So then there's quite a lot of development until the war ended. And then the scientists and engineer look back, hey, we can actually use some concept from this war era to our industry or our company, plant factory. So basically, it's a decision-making method developed instead of military. And so to decide, so it's what's the relation between those logistic and decision making, because everything will end up as a decision. Whether you want to decide to send those food, send those tank, rifle, or you will decide to not send it. So it's to help the operation. That's why the name is operations. Military operation and now operation factory. Yeah. And in this case, it used mathematical model. Yeah. To similar to the mathematical optimacy class, to model the real world problem or the factory problem into mathematical model and find the solution. Okay. And then we also have another keyword, deterministic and probabilistic. Deterministic is everything you just determine, no change, no uncertainty, everything is certain, while probabilistic has some uncertainty. You will have more this, I will learn more about probabilistic in the second class. Yeah. So I kind of like make it split up. In total, the PPT is 72 pages. Our is science and also art. So you learn later on that is also part of kind of like art. Yeah. I don't know how to say it. Different people might have different way to formulate the problem. Yeah. Might have different view, and that's called the art, including how to find the solution. Some are very, what can I say, creative to find a solution that is not standard, but it works. It's also being accepted. Yeah. Now, after the war, it's been applied in a lot of area. In manufacturing, there is several area within the manufacturing, but also services, logistics definitely, and other transportation, environment, healthcare, and some are, for example, that you can read later on. Yeah. There is some that related to cost reduction, some related to quality, some related to risk, and so many areas. Software, we have Excel. We can use the Excel for linear programming. We have also Windows, Simplex. Python is not here, but it's supposed to be here. Because you use Python as well last semester. Yeah. Good class.
For practical.
Yeah, practical. Is it difficult?
Yeah. Difficult, but
Is it the first time learning about coding in Python, or you learned that before?
but it's easy for you.
First time.
For me, it's first time.
First time, but for you,
Nowadays, they start to learn Python during the elementary school.
Oh.
But Python for kids,
ah,
or coding for kids.
Coding for kids.
Elementary school or middle school. Make it easier, make it simpler. And they usually like to use Python because it's free. But the other is also free, but yeah. But Excel is should not be free actually, but it's not official. And you can use the unofficial one still. But you can do this one. Yeah. And GAMS, the bottom one is also very expensive. It's very powerful, but very expensive. Everything here, we have seat plans, we have from solver from here. It's compiled into one GAMS. So that's why it's very expensive. And also, I use this during my GAMS. I use Python first, but then I see some limitation for my dissertation, then I change it to GAMS. So the professor use GAMS. What is the project? Yeah, it's very specific because of that, and it's also used for intelligence. For the optimization problem. Okay? Not only data engineering, the other management also use it. Yeah. But we should be the one who use a lot because this is one of the core knowledge for data engineering, operation research. Here. Okay, I'm going to skip this. I will show you this, and we will discuss about this in each meetings. Yeah. And I want you to show you this. Yes. Here. The process in the OR study. First, you got to define the problem in a company or in a factory. I think I already explained to you a bit before, but in the other class, this one is the define the problem, find what the problem is, develop model using mathematical model, find the data that you need to run the model, and then find the solution that you want to have. Check, test, analyze, and we have the sensitivity analysis to see what if there is something changed, what happened to the result, and actually implement. Okay, here, define the problem, finding what's the problem. You can get help also from other departments. But problem could be the problem within the company, could be outside, also could be the voice of customer. What's the customer want? So you want to change from that information which is qualitative survey interview into quantitative with unit of measurement, rupiah, meters, kilogram. That's quantitative. Here, so what's the problem? What do you want to maximize or minimize? That I explained to you before. And we will you do this a lot. Developing a model. Yeah. Develop a model until next week or partly today. To catch up to train how to model from a problem to a mathematical formula. Then input data, acquire data, develop solution which we the other chapter for the next 2 weeks, the whole semester is there are several solutions that you can use, and there is other that you should not use because it's not suitable. So here, test solution, analyzing the result, implement the procedure. Here, right, and the model. The real world is big, but then you can find the red one, which is the assumed one, to use the model, because if it's too complex, then the model is also will be too complex, and you will really have hard time finding the solution. So you use part of the real world system, okay, to make the model. It will be graph, formula, chart, picture, and basically to show what is your problem, what are you doing with your what is your working, yeah, what do you want to achieve, yeah, what do you want to achieve, okay, this, but then model has will need to be standardized, okay, even in mathematical formulation it has to be standard, yeah, because nowadays you can also see some of the mathematical model online. You can even ask ChatGPT to get Python code. Very simple one, and usually it's not working well if you actually try to run it. Yeah, but this, yeah, it's now still developing. You can try. You can at least some reference. But in here we study the basic one. What's behind what's ChatGPT or Python. Yeah, because there too, the brain is still you. You human is still the one who knows. Technology, computer, and I just learning from. We ask them to help us, like Captain, and brings to us, but they help us to make it faster, okay? Or even help you guys to study, to learn and study about this. Okay, need a standard. Not just in Indonesia, but people around the world still understand what you're doing, what mathematical model is you try to convey. So we have some properties of the model that should be simple, complete, adaptive. Adaptive means if the problem change, should adapt well. If the problem change and you need to reform to change the model, then it's not so adaptive. Should be like that, adaptive, and has to produce information that is relevant and appropriate. You need to understand what you need to find out. So we don't need information that are not relevant. Say cost related, you need to find information about cost. What is related to the cost? some mathematical model has analytic and simulation, and the analytic one has descriptive and normative, which then in the next page you can read later. Yeah, what's the meaning? Yeah, descriptive means to describe what the system is, but normative to recommend what's the solution. Yeah. Mostly we'll deal with the mathematical one in this class, and this class we'll deal with the linear, mostly the integer, and deterministic. So this is type of model that in OR, when you present to or you show the model, the algorithm, they will first they will think what type of model it is. Are you static or dynamic model? Are you linear or non-linear model? Integer, non-integer, and deterministic or stochastic? Yeah. Say linear, everything is linear. There is no curve. If you draw your model into an x and y coordinate, there is no curve. Non-linear, integer, non-integer. Mostly is non-integer, which means decimal is fine. For integer, you only have 1, 2, 3. Okay. Actually, finding the integer solution is more difficult than non-integer. Deterministic, like I said, everything is determined. Stochastic, there is a probability or uncertainty. Yeah. But static and dynamic is also different sign. Yeah. If it's static, it involves sequence of decision over do not involve sequence. While dynamic, it involves sequence. What does it mean? Say if you model decide to set up how many goods should be sent to the warehouse from the factory. If it's static, you only set for one time and finish. Yeah. But if it's dynamic, you set for several days. And tomorrow's might be different than today. Because tomorrow's plan depends on what's today. Yeah. If today we send a lot to this warehouse, then tomorrow we might not send a lot. So the decision will multi-level, multiple variables. It's more complex. Okay? So you need to clearly define to the audience, who's the audience? Could be a friend, could be someone on the internet, the collaboration, who will collaborate, or your me, and also later on in the workplace is your manager, and your boss. Or if you are the boss, you're a client. So you have to make sure that they know which one, especially those who knows about OR or operating systems. Okay. Here I already explained to you what is this. Some of the model that included in the deterministic are this: linear network, integer, including non-linear one. But actually in linear we can add some stochastic factor. Here. You learn more on the right side of the second next semester. And it's uncertain. Okay? Mathematical model, I've taught you before a bit, about model mathematically, but I want you to here. What's included in mathematical model? We have decision variable, we have parameter, we have probability function, we have limitation. I said this before, is it? Did I? The decision variable is the one that we need to find. Your resolution should be, what's the variable? Parameter should be, say, the capacity, the availability, that is constant. Object function is, do you want to maximize or minimize something? Maximize profit, minimize cost. And limitation is the condition that limit the problem. Yeah. Speaking of variable, we have independent and we have dependent variable. Yeah. Independent is uncontrollable variable, while dependent is the one that we can control. We'll go back to this place. Yeah. One example of this independent and dependent. Yeah. I think I left this with you a bit, but let me repeat it. Say you want to know how many should you produce in the factory, or how many chairs you produce. It's very dependent on how many workers you have, how many machine you have, machine that to make this chair, how many raw material and other things that you need to have. So you can see which one is dependent and which one is independent. Yeah. The product of the chair is dependent. Yeah. Probably the other factor. Okay. We have verification, we have validation, which we also learn later on. But basically verification is, well, when you model something, you will model usually based on scratch, draw a picture, diagram, and then make into mathematical model. And that picture diagram is you make it to make you easily understand the real world what it's about. So the verification is to check whether your model, mathematical model, is based on the conceptual model that you have used. And validation is to check that mathematical model and conceptual, it is really still according to the real world. So verification should go first before validation. And this validation will check with the real world. Okay. Sensitive analysis, we will go back to this place, but this one is one that make you stand out actually. If you are working in a company and you need to do some opportunity research work, this is the one that make you stand out. Can you do the sensitivity analysis? Or if you and your friend can you do it better? Because the solution is maybe the same. With the model or with different model, the solution will be to find optimal. But then this will be fine. Because then the manager will almost always ask, what if we change this? What if we change that? What's the risk? Well, we need adjustment. And you need this to make it quicker. You cannot just, okay, let's change this variable and change the parameter. You need to rerun the model again, that's too long. Yeah. If you know this and you can do it quickly and you have more in-depth understanding, then you will stand out more than your friend, which means you will get more promotion. Yeah, more salary. If you're the worker. If you're the owner, then the client will like you more than the other company. Yeah. So yeah, I like this part because it can give me more money. And I will go with this. And more about this and more about action. Here, linear programming. Basically, everything is linear. The first step is linear programming, and the first session is everything linear programming. Everything is linear, and this is the one that I want you to be more familiar. The one that I mentioned before, the variable, we use X notation, a symbol X as a variable. Yeah, xi, which means a variable in I could be anything. The number of products of product 1, which means I is 1. X2, the number of product 2, and so on. Yeah. So xi. And then we have derivative. The first one is xi, xj. We have parameter. We have objective function. We have constraint. So this is the one that you will look about and we will make yourself. based on the problem. C is usually cost. For example, say, oh, you need 10 people. So what is the cost? The salary is C. 10 people multiply with the salary of rupiah or dollar. Yeah, usually C. B is usually capacity. Like, yeah, you need 10 people to make this product, but the company has total 50 people. So you use 1/5 of the whole company's capacity. Yeah. And A is the one related with science. We have constraint, which is the limitation, like usually all this function has to be less than B, for example, has a capacity, or should be more than a certain settings, or equal, exactly equal. And X should be more than 0, or 0. Should not be negative. This is like very standard from that. It's always need to be mentioned, even though you can get bored with mentioning this. This, you can have how many worker? -10. What's the minimum? So we need to fire 10 worker to make this product. Doesn't make sense. And so, but also in the programming, if you don't mention this, it can be error, or the result will be weird. Yeah, wrong. This is the mathematical model, or in a table, you will also use a lot of table of this section. This is the source, this is the capacity, this is the cost, and this is the parameter that relate to every problem. Yeah. But in books, in papers, what you see more is something like this: min or max. Z, which is the objective function, say cost. You want to minimize the cost, and cost is, we got the cost from adding C multiplied with X. Right? C is the salary of the worker, and then C is also the cost of raw material, and so on. Okay, ST is subject to this constraint. What's the X? Also, if it's in max, usually it is shaped like this. Usually, more in the common side, and the right side for the minimums. Okay. More detailed explanation about what is Z, X, C, B. I said usually is because to make it easier to understand, but it doesn't always have to be capacity. For example, B could also be something else. Yeah. One of the source I that is available for allocation to activities. So you have IJ and sometimes IJK, okay, LMs. You learn a bit about this kind of notation is linear algebra. Yeah. And actually it's the form of matrix. This is a matrix. So based on that matrix, you learn more method. Yeah. Okay. Any question up to this point?
For like linear programming, is C contains a value that is called like limitation. So, not C but B, like the capacity. For B, does it mean like the limitation for the, for example, like the company?
Yes, but if you say not only linear, every other mathematical model, B is usually limitation or rule, government rule, or other factor. Yeah, but the linear is just that everything is linear. There is no quadratic. To be simply linear. And you don't really multiply x with another x, because that will be non-linear. This is only C multiplied with x. C is constant, x is variable. So you only multiply variable with a constant. You don't multiply with another variable. Then it's going to be non-linear. There is a way, but it's not in this section, first section. Yeah? Alright. And there's some assumption of linear programming that has to be proportional. Because if linear, basically on math, and between C and X or parameter or constant with variable should be able to be added. You need to add Cx plus C1x1 plus C2x2. This is also math. Should be divided. Uncertain because in linear, certain. But though we can inject some uncertainty, but not in our case. Okay. And then we have some terminology or the naming about solution or the result. We have feasible region, we have feasible solution, we have infeasible solution, we have optimal solution. So we have several types of solutions. Yeah. First is a feasible region. Basically, when you try to find something, there is so many possibilities, so many solutions. I know that you need to find the optimal one, but this solution should be in the region of solutions. If you draw an x and y coordinate, then it's like a picture, the whole region. While feasible solution is some of the point that can be the solution. Infeasible is the one that is outside the region, so it's not possible. You could find those things there. Also the optimal, the one that you need to find. The optimal solution. Yeah. Yeah, this is the one that you need to find. Okay. Also we have this condition unbounded corner point that we will discuss later. Okay. Any question?
For the decision parameter, decision variable, does it for linear programming only has contain one, like xi only?
Decision variable is for all time because that's the one that you want to find. Not just linear. Basically for every other time.
So, but for like, if we're starting operation research, what is the first thing, the first component that we need to find? Is it like the variable or the parameter? Or?
Oh yeah, but then you define the problem, which because variable parameter is in mathematical form, right? So you need to find sure the variable. What are you trying to find? Yes, the variable, but also then what's define this variable, which is the parameter, right? Because then you will want to know the purpose. Yeah, like you want to know how many people, but for what? How many people to work in the factory for this product, so you will reduce the cost, for example. That means okay, many people for which product, for which type of X, and then the parameter was the wage or what relate to those people. Maybe not just salary, something else maybe. Their skill, for example. Yeah. And then to reach the goal, which is the overall cost. So usually you parameter variable is what you define an objective function. Everything has the same time. Sometimes after you set up the mathematical problem, then you realize that I need another variable. Otherwise it won't work. Sometimes it happens. Yeah. But it's going to be better if I show you the process of modeling. Okay. Right. Let's do it. Supposed to be this, but then last week I didn't do the class, so let's go to the other one. This thing is fine. Everyone feels sleepy. You can take
What for the software of this? Should we use only Excel or?
Sorry, what you say?
For the software, we only use Excel or this some also programming we should use?
mostly manual because you learn the basic, but we also use the app. You could use Excel if you want, but we'll use the one that is easy. Python, sure, you can use that.
Python.
Same as the Slingo, same as Excel, to model based on their language and see the results. But then you only use it to confirm or what your own calculation.
Do we need to use Visual Studio Code?
And this is no practical, so it's we do it again. The main thing is those are only two. Yeah. So now I can show you the main thing after this. We go to the model. Okay. Another question? Okay, let's do partly modeling today and next week the other model. Actually, we have more. There's more. This is the house. Let me open the file first. Oh, that's actually still in Indonesia, so okay, I will kind of translate a bit, yeah. I will change it to. I haven't translated, but I think it's okay. It's okay. Formulating model to linear programming. Okay, let's start. This is the one that always you need to do during the exam. Okay, ready?
Yeah.
Okay. This is the first time that you need to do for the exam. Okay. To model with a linear solution. Next week I will try to understand. Basically, the principle is still the same. You have objective function, fungsi tujuan. We have constraint or fungsi batasan. Same concept. We have variable, decision variable. We have objective function. We have constraint. And then you also, for example, you have x. It's the same as I explained just during this PPT, previous file. Variable tulisan or decision variable x. And you have fungsi tujuan or objective function to minimize or to maximize the benefit. Okay? Same concept as the previous PPT. And this is constraint, say, only 40 hours of worker. And worker doesn't always mean number of people. It could be hours. Yeah, because even though you have so many people but they're doing nothing, they're not working. They just stand by. But this is hours. And this will also actually define how many people. So one day is how many hours of work normally in a factory, you know? Around 8. Yeah, one shift. Yeah, depends. But normally 8, each one with 1 hour of rest for praying, lunch. Yeah. So, but maybe 7 actually. And 7 will be reduced by the people who actually work, who not really working, smoking, or drinking coffee somewhere in the factory. That also happen. If they are not being assigned to work, they will go somewhere to rest. Okay. So in total 40 hours. So if it says 40 hours, 40 jam, while one day is 8 hours, that means how many days is actually 5 days. Yeah, assuming 8 hours. Of course, people who work for 8 hours, they always need to rest. So resting is paid rest time. Yeah. Otherwise they won't be able to work again. They too tired. Time out. Only Monday to Friday. Sometimes till Saturday, which is more than 40. For example, this is limitation. Then you have this same Z, X, C, B, A like previously, yeah, and same standard mathematical formulation, max or minimize, same table as well as the previous one, same assumption, proportionality, additivity, divisibility, and then certainty, yeah. But then this one. There it is. I will try to translate it. You can learn it. Yeah. So there's a company, the name is Barang Maju Bersama, which produce two products every day, which is a bow and what is that here? A cup. It's a cup again. Bowl and a cup. Okay. The company has two sumber daya resources, which is limited. Yeah, and it's used to produce those products, two products, cup, bowl and a cup, and the raw material, or not the material, the resource are three: tanah liat, clay, and people, person. So very simple one. They don't consider anything else. To make a bowl and a cup, you need clay and people who work. Yeah, those two results. And it's limited. The company want to know how many bowl and how many cup that need to be produced every day in order to maximize the profit. Yeah. So the goal is to maximize the profit. The product is bowl and cup. The resource is the raw material, which is clay, and people, worker. And then you need, of course, you need some data. You need this. What are the needs? So, bowl will need 1 hour to make with 1 pound of clay, and it will result in $4 for rupiah. That's the profit. For a cup, it is 2 hours more time, but less raw material. Only 3 pounds of clay, and the profit is more, $3. And we have this information. We have 40 hours of worker. So let's say this is capacity is what we have. Every day, this is every day. We have 120 pounds of raw material every day, for production. This problem needs to be modeled as a mathematical linear programming problem, and to put all that we have into one set of mathematical problem. So this is one example. Actually, very easy one. If it's going to the UTS, it's one example of an easy question. You just need to formulate this. You don't even need to find the solution. Yeah. So now let's see what variable that we have. Definitely the variable is the one that we are looking for. The company was looking for how many should we make. Yeah. So you need to find the rest will be over here. How many should we make? Glass, yeah. Bowl and the cup. So that definitely that's the variable. Yeah. You need to, okay, what's the bowl? Let's see, say x1 is the bowl, x2 is the cup. Okay. Let's make that as the variable, decision variable. Okay. What's the goal? To maximize the profit. So we need to find the profit. So what is profit? How can we find the profit? How can you find the formula of the profit?
Every
alpha is profit. Right?
Oh.
So what should we do this? What should we connect this 4 and 5? This is profit. Each bowl produced will have profit of $4. Each cup will have a profit of $5. So how can we connect this?
The profit for both is equal to the hour, the work hour.
Work hour is should be a cost. To produce, you need to have a cost. Someone working, but you already know. They already give you the profit straight away. Sometimes they don't give you the profit. You need to calculate by the amount sell minus cost, but they already give you this. So you don't calculate that. So what should we connect this profit into what variable or parameter? This is actually parameter. Profit is parameter because it's there. You don't change. Right? But variable will change. How many bowl, how many cup you make, it's up to you. You decide. But the profit does not change. Each bowl will have $4. Each cup will have $5. So for the objective function, which is z to maximize profit, you just multiply the profit of the bowl with the number of the bowl you make. You need to multiply the profit of the cup, which is 5, with the number of the cup that you make. Right? And then you add it, become the total profit. So this is the one that you need to make this out. Z is the profit. And how can you find the profit? If we know the profit for one item, you just multiply how many items you make. X1 is how many bowl you make. If it's X1 too, X1 is 1, that means you only make 1. If X1 is 100, you make 100 bowl. Multiply with the $4, then you get the profit. Yeah. Also the X2, yeah, profit of the cup. Okay. And Z is the total profit, which you want to maximize, right? So this is the objective function to maximize Z, and Z is 4x1 plus 5x. Any question for this formula?
When is the cost there, like the work?
Because we will be not in constraint. Constraint. Yeah. Within constraint. If you don't know what's the profit, they don't give you. Instead, they give you the gross revenue or the income total. Then you need to reduce that with the cost to get profit. The one that you receive minus the cost is the profit.
So is there maybe any specific formula that we use it if the cost we profit?
You will need to have another data. This one, they already give you the profit data. That's why it's very easy because just give you the profit. Sometimes you need to calculate your own. But then you have another data. So let's go to the constraint batas application. And what kind of constraint should we do? Depend on the problem. Here, let's go back here. Very good. To make bow and cup, we need resources. What are the resources? Tanah liat, clay, and tenaga kerja or worker.
Work.
So, what should be the constraint about them, about the resources? Yeah, about the resources. Easily you can try to, with this problem, those are the only constraints. that I can see. Except if the company, the management asks you, oh, minimum you cannot make only 10, minimum you have to make 50, for example, as a management goal or something. Then another constraint you need to add. This one there is no minimum, no maximum. Oh, there might be some maximum, yeah, but there's no minimum. You can make a 0 cup and 100 bowl. It's fine. There's no limitation. Okay, but the resources definitely are clay and worker. So the constraint are this: worker and raw material or the clay. Yeah. So what should we make about the worker? We know that we have this information about worker. The maximum is only 40 hours per day of work of worker, right? And each product need hours. 1 hour for one bowl and 2 hours to make one cup. Now we can see how can we relate the capacity of 40 hours to those hours, right? If we make 1 bowl and 0 cup, we will use how many hours? 1 bowl, which is mangkok, and 0 cup, which is sanggit. How many hours do you use? 1 hour.
1 hour.
You have only 1 mangkok or 1 bowl. Yeah. So you already use 1 hour out of 40 hours. Okay. If you use 2 bowl, only 2 hours. That means you need to multiply the number of the product that you make with the hour. So here, we need to multiply. This is the number of the hour for a bowl, 1 hour to make 1 bowl, okay? And 2 hours to make 1 cup. You need to multiply this. On x1 plus 2x2. Okay? And what's the limitation? 40 hours. Whatever you make in total, x1 and x2, or whenever you make, cannot be more than 40 hours. Okay? So this is the model of the constraint related to the worker. Okay, at this time, in the case is worker hour. Any question? Here?
For this example, it's easy. The other side.
Don't worry. We have another example. How about the raw material? We have recipe. Here, the middle one is our worker, but then we have pond, which is the tanah liat or the clay. We need that resource. Making 1 bowl, we need 4 pounds of clay. Making 1 cup, we need 3 pounds of raw material, which is clay. Same like the hours, so we need to multiply the number of product we make with the weight of the raw material. And we have the maximum weight, maximum available clay is 120. It's similar. Need to multiply 4 pounds with the number of cup, x1, and multiply 3 pounds with the number of the cup that you make, x2. And everything has to be less than equal to 100, which is could be 120, 120 could be 0. I don't know. Maybe, even though maybe that's not logical. We want to know. We want to produce, because so then we have one. But then, can it be negative? We only this. If we put negative 10 for x1 and negative 20 for x2, will it still satisfy this equation? It's still satisfied. It only say less than or equal to 120. Minus 1 million is still less than 120. So you need to add more constraint to make sure that you don't have that negative. Here, x1 and x2 both has to be 0. Yeah. 0. Yeah. Okay. So you need to make that. Z maximize z equal to 4x1 plus 5x2 with the st or constraint. First constraint is 1x1 plus 2x2 less than equal to 40. And you can add explanation. What is this constraint about? It's about the work hour. The second constraint is about the raw material or the clay. And the third constraint just logical constraint. Usually, you don't need any explanation. But this is the one that you want to put on the paper during with the S. And Y is correct. Okay. Now finish for number 1. Easy. Should be easy for this. Any question?
How much we have more than 2 variables.
Sure.
So we use the same, right?
Still similar, but then you have extreme, which is something else.
Maybe for total, which is z, maybe we can plus, there is 4x1 plus 5x2, there is 1 plus x3 blah blah blah.
You see, in this case, another product, right? Bowl, cup, and I don't know, glass, or any other product. But it has to be same type. Not same type, sorry. Has to be same unit. The unit is dollar. Remember that Z is profit? Profit, right? So the unit measurement of Z is dollar. So whatever you do here, you add, has to be still in dollar. This is the number of bowl, number of cup, but you multiply with the dollar. So if you want to have x3, you need to multiply with a dollar. Right? To be any product, right? Yeah. Or minus something, which there is some requirement. But still need to multiply with unit of dollar. Since Z is dollar. Yeah. Any more question?
Maybe there's like decision variable has something to do that what we are going to optimize, so it's going to be the decision variable, just like the profit.
The profit will be depend on the variable, the x1 and x2. So remember, profit is also variable, but it depends on the independent variable. The independent variable is the number of cup, number of x1, x2, and x1. Yeah, that you decide how many to make, and then z is dependent on. You will get z if you already decide how many x1, x2, and how many should you make. That's come the solution method. You will learn more. You do it manually, of course you can do mathematically also, like mathematical optimization class. Of course there is simple way to do it, sure. But this is a simple example. When the example is more complex, then you need some other method. Yeah. Any other question?
Pak, actually, can I go to the bathroom?
Alright, I plan to finish at 5, so let's do 10 minutes. Hopefully, the next week we can do another example. Let's increase the level of the problem. Okay, sorry I'm still in the share, but I'm interested in you. It's a big Greek problem. Okay. A bakery make bread, sandwich of bread, which has fillings. The bread has fillings of meat, and the meat is a mixture of beef and chicken. Yeah. Mixture of beef and chicken. Okay. That's the time of the one that they use now. Fillings, bread with fillings. Okay. So now let's talk about, okay, what about the beef? The beef that they have, the raw material, let's say, that they have, has 80% of meat and 20% of lemak, which is fat. For a beef, 80% is meat and 20% is fat or protein. And the price is 8,000 rupiah per ounce. The price of the raw material, they need to buy from the market, but the meat that they buy, every ounce is 8,000 rupiah. Now we have cost now. Okay. And then the second raw material for this bread, chicken, has 68% of meat or protein and 32% of fat. But it's cheaper. It's 6,000 rupiah per ounce. Okay? I mean, those percentage is for any weight of the meat. Yeah. Now it's more detailed, not just the number of clay. We have percentage. How many of the type of meat that need to be used for 1 ounce of bread? So basically it asks, so how many percent, how many ounce you use, or less than ounce actually, of the beef and how many of the chicken for 1 ounce of bread? That means we will use meat, could be 1 ounce of beef and 0 ounce of chicken, but we cannot make more than 1 ounce for every 1 ounce of bread. So that means could be half ounce of beef and half ounce of chicken, but in total is 1 ounce. Okay, but how many ounce each of the beef and chicken? If we want to minimize the price, the cost. Yeah. Harganya means the cost in this case, not the selling price. The selling price, we say this is just the cost. Then you have additional one to maintain the fat of the bread because of the not more than 25%. So the most of the fat, whatever it is you use the beef or the chicken, cannot be more than 25% fat. Yeah, that means the protein, maximum protein should be 75% protein. Could be more protein, but the fat definitely not more than 25. Could be 20, could be 0 even. Could be 0? You think could be 0 fat?
Yes.
Using this, actually you cannot. Because every beef, every ounce beef, you always have 20% fat. Every ounce of chicken, you always have 32% of fat. So this is assuming that you do not separate the fat. You cannot have 0 fat actually. That means if you have 0 fat, you don't use any meat. So the bread is just bread. No meat. And maybe nobody will buy if you say this is a beef bread and then you buy there is no beef. Then no one will buy it. Okay.
Sorry.
But in the first like line, the bakery make a bread using beef and chicken without.
Yeah, maybe I should take out the tanpa lemak. They will be still maybe low fat. Should be without lemak. Should not be tanpa lemak. Should be low fat. It should be, if it's tanpa, without zero. We need another process, but it's not described. So, the problem is anything. What should be the variable? What is the thing that we need to find out? Actually, it's almost very explicitly mentioned. The one that's being asked. What's he asked? How many meat should be used for 1 ounce of bread? That's the question. So that should be the variable as well. So the variable should be how many ounce of beef and how many ounce of chicken. The x is this. X1 is ounce of beef, and X2 is ounce of chicken. Right? And speaking of ounce, it doesn't mean 1 or 2 ounce, 0 point something. It should be less than 1 ounce. Any question? This part? Yeah. It is being asked. And then after that, you need to find out what's your goal. For what? You need to find this to get something. The goal, what is the goal? To minimize the price, minimumkan harga, minimize the price, the cost. That means you need to multiply this with something related to the cost, which is the cost of raw material, cost of beef, and the cost of chicken. So then minimize Z total cost and $8 or was it dollar? Rupiah, but it was 8,000. We can make it simple as 8, and later the final solution just multiply with 1,000. To make it simpler is good, right? Multiply with 8, not 8,000. So cost for 1 ounce of beef, yeah, beef, and then 6,000 rupiah or 6 times the ounce of chicken, and you add it. That's it. That's the Z, right? There you go. Then we need to go to the constraint. We need to go to the constraint. We have that fat condition that we need to limit the fat until up to max 25%. How can we get that fat? Where's the data of that fat? Lemak is fat in this case. Which percentage then that related to the fat? Yeah, 20 and 33 because that's lemak and that's fat. The other is the protein. There is no limitation on protein. They didn't say anything, but they want to make the fat cannot be more than 25. So let's take a look at the fat. 20% and 32% of what? Of the meat, of the raw material, of the X and of the Y. Of the X1 and X2. Each X1 and X2 will have fat. How many fat? There, the top. 1 ounce of X1 has 20% fat. 1 ounce of X2, which was chicken, no?
Yes.
Go the other way around. Has 32 percent of fat. Percent is 0.2 and 0.32. And has to be less than or equal to 25%. So if you use 1 on of x1 and 0 on of x2, you have 20%, which is already equal to less than 25%.
So for the question about to minimize the price, so the answer is z equals 8 times x1 plus 6 times x2. This is your answer. Final
For
answer.
yes, for the cost, related to the cost for the goal,
So that's the final answer.
to find the objective function. The objective function is the following, which will help you, because if you make 1 x1 and 0 x2, then you get a z. You make 1 x2 and 0 x1, you get a z. Which one is the best? Then you need to have this as a limit. And the question for the top, don't check the bottom section, the top section first. Any question? Why is 0.2 and 0.32?
Because it's 20%, and for the chicken is 32%.
Of fat. And total fat should be not more than 25%. Protein, they don't care.
Sorry, for the like the variables. So so the value for the x1 and x2 is the same, equal to 1. But how does that comprehend to the
Well, the bottom one?
yeah?
Not yet. Let's check the top section first. If you study the more one, let's go to the bottom section. Ready? Okay. The bottom section, the limitation of the total weight. So apparently we cannot have more than 1 ounce. Why? There you go. How many meat that we need to use for 1 ounce of bread? So the ounce of bread, the weight of bread is 1 ounce. Or say the weight of the meat, total weight for 1 bread has to be 1 ounce. I know the bread should be a bit more, they kind of like, okay, just assume the weight of the bread depends only on the meat. So there, except if they have additional, not only beef and chicken, but they have meat, then the additional variable. But this one to make it simpler, 1 bread is only 1 ounce. They don't want to make more than 1 ounce. That means, here, going back to your question, here, x1 and x2 have to be equal, not less than. Because if it's less than, then the bread becomes small. And you will not sell well. If it's more than 1, yes, it will be big. But then you need to charge more. And you don't want that because then you need, as from a financial point of view. The best way is just 1 ounce of bread. Okay? Cannot be less than or more, it has to be exactly. So this limits the problem. One thing missing from here, there should be another constraint.
Is it the price?
Cost, you mean? The cost
The
is
cost.
here. 8,000 and 6,000 is here. Something else missing.
Is the price, is it beef or chicken?
X1 is beef, X2 is chicken.
Also, if we want to integrate, we can mix beef and chicken.
We have to mix. Or use 1 if you want. If that's the optimal one, sure. 1 ounce of beef and 0 ounce of chicken. Still fine, I think so. Right? But how about 1 ounce of chicken and 0 ounce of beef? Total is still 1. This is 0. This is 1. Still fine, right?
Yes.
But
for the formula, it's 3 will not be more than 25.
because if this is 0, this is 1, 32, 0.32 is more than 1. It's not fine.
X2 has to be less than 1. Check.
Yeah,
Yeah.
point something. Decimal. Or 0. But which one? That's what we want to find out from this plot, this model, the solution that we want to find. But there is something else missing. And it,
Yeah, is it the X2 has to be less than 1? Because
1. X2 has to be less than 1 from here.
yeah.
X1 and X2, addition, you add everything, all the meat has to be equal to 1.
Yes.
Yeah.
But then we make another limitation for the chicken only.
Do you need to? Because you have this. If you need to add X2, it has to be less than 1. It's already represented by this. X2 will be automatically less than 1. Because if you put 1 in here, it's going to be error.
Or maybe we have to make the limitation for each meat that we use. How much meat that we use in one time.
So limitation how much meat here. In total has to be 1 ounce. So it will be less, can be more than 1 ounce for the product, yeah. When we ask why, that is kitchen business.
Maybe the meat, percentage of meat, the minimum.
Minimum 0. Oh, is it? What do you think? What's the minimum of the meat?
Minimum is like
Has to be
25.
The minimum pound of meat. It is pound, in this case it's pound. The weight of meat.
It has to be more than 0.
Yeah. Here. The last one. The logical constraint, the last one. Always be the last one. You gotta have a negative. What does it mean negative? 1 pound of beef. Yeah. And if you don't put this in the Python, if you don't put this in the Lingo or in the Excel, you won't get the result. Yeah. You will get the result, but then negative something. Yeah. Doesn't make sense. So this is minimize z, min z equal to 8x1 plus 6x2 in read 1 or in 1,000 of rupiah. That so you won't forget. It's actually 8,000 and 6,000. And constraint first, second, and third constraint, and then add what's it about. What's the first constraint about? Always about seven. Composition, and then second one's about the weight of the meat or the bread in this case, and non-negative constraint. Any question? That's the mathematical model. That's the-
Is this one of the example for how we exam?
Yeah, this could be. I mean, the first number or second number is always about the model. Could be this. Could be other thing, which is the next example for next week. And yeah, it's another question related to this.
Maybe what's the difference from this model and the next other model? What's the main difference?
What do you think was the difference? basically it's the same. We have objective function, we have constraint, we have variable, we have parameter, which is parameter is the cost, is the what, going to the percentage, is a parameter. It's a constant.
Is it maybe for like example non-linear? Maybe they have like other constraint about like inflation, so the value is.
If it's nonlinear, then you might have another problem that is x1 square. That's nonlinear. Or x1 multiplied with x2 for another problem. That's also nonlinear. Okay. Yeah. But we won't use that in this section. Okay. Do you think this is more difficult than the previous problem? To model with mathematical model?
Yes.
Yeah, a little bit, yeah.
Yeah.
Because you have percentage, percent. Previously was just number of people, number of clay, the pound of clay, but this one is percent. And even this one does not ask you about any about protein or the meat, not the fat. This is also okay. All right, let's continue next week. I think we still have some other example, but I will try to translate. How many examples?
Do you want to send it to me?
Yes, but I need to cut from the next example. Otherwise, it's going to be like a still crash.
Oh, yeah. I'm actually a bit confused about the first example.
Okay, let's go back. Are we here now?
Okay, nice.
Okay.
So the question is, they want to maximize profit.
Yes.
Then the first thing that we need to do for modeling is, so the goal is x1, the cup is x2, right? Then what should we do?
Find how can we use this variable to get our goal.
Maximize profit, right?
Yes. So that's why we need to multiply this figure with profit. Because each one goal has $4 profit. Each one cup that we produce has $5 profit.
So x1, for x1, we're gonna
For x1, yes, for x1. And 5x2 is the profit. So this is profit for goal, profit for cup, and Z is total profit.
Oh, biar dapat atribut.
It's a big question.
Yeah.
Decide that.
For the objective, yes. That's the profit. Only that.